Okay, so carrying on phase of matter. Now what is melting? Okay, imagine you had a lattice of particles. Okay, they're all nicely bonded together. So now because of this, they've got a nice strong potential energy. Now if you provide more potential energy, then they can move further apart away from the other ones. Okay, so process of melting is providing a potential energy to let them move around to different positions. Internal energy is the sum of all potential and kinetic energies in a object or some matter or in a body. Okay, so if you think about it, the vibrations and so on is kinetic, so there's that inside an atom. There's also, not inside an atom, inside molecules and so on. But there's also the sort of the bonding between them that is also important. Pressure, what is it? Essentially you could use the formula to find this one. It's force over area, so is force per unit area, where the force is 90 degrees to the area. Okay. Now, what's the derived in SI unit? Well, the derived unit, chuck it in. You know, you can start working out what's force kg, ms to the -2 divided by metre squared, and go from there. However, the SI unit is equal to the Pascal. Okay, just to give you an idea of reference, atmospheric pressure is 10 to the 5 pascals. Okay, so quite large. Now what is it? Essentially it's like a piercing force. It's pressure that will puncture things, it's not a force. Okay, so it's a combination of force to the area. So a pin is much better at puncturing things than something like a wooden cube. Okay, you could apply the same force for both of them, but it's more likely going to be a pin that punches something because of the small area and hence the large pressure. So P equals F divided by A. If you have a small area, you could have a large pressure. Essentially that's what that's talking about. So, work done by an expanding gas. Consider a piston in a cylinder. The pressure inside the piston is pushing the piston out a distance x. Okay, so this thing is filled up with a pressure P, and it's going to move this piston outwards, okay, because there's a force against it. Okay, there's a pressure, and we've moved a distance x. Okay, and the size of the piston is area A. What we're going to do is write down the formula for the work done by the expanding gas. Use x as the distance. So defining formula for work, Fx. Write down the formula for the pressure due to the pressure of the gas on the surface A. Okay, and we're going to make F the subject. So F equals, from pressure equals force over area, must be pressure times area. Substitute the last formula, the force equals pressure times area, into the first one. So you get work equals pressure times area times x. Now if you think about a cylinder, okay, area A multiplied by height x is equal to a volume. Okay, so in this case the work done is equal to pressure times change in volume.